In that last video, we talked about observational studies where the researchers just observe and collect the data and analyze it from there. So they're not affecting anything. In this video, we're looking at experiments, and we're going to look specifically at randomized experiments. So in a controlled randomized experiment, researchers assign treatments to groups of subjects and measure a response variable. So there's going to be some treatment in there. So that could be, like I said before, like a drug study. It could be providing a drug to take. It could be implementing an exercise routine. Something where you're changing this person or this thing's daily life. It doesn't even need to be a person. So what we're going to do is talk about all these pieces because there are a lot of words in here, like this idea of control and randomness and treatments and response variable. So we're going to talk about how we can implement all of those ideas. And then what we can do is, if we design this well enough, it can lead to claims of causation. So at the end of the last video, I was saying how we'd love to get this idea of cause and effect. This thing causes this effect. And with that, making such a strong claim, we need to make sure there are no lurking variables in there. And a lot of this control and randomness that we implement in here is going to help eliminate those lurking variables so that we can claim cause and effect. All right, so in this example, we're going to look at chia seeds and how that relates to weight loss. So let's talk about the data that they collected. So there's some background there, but let's look at this 2009 study. A team of researchers recruited 38 men. I'm going to go ahead and highlight this. They recruited 38 men and divided them randomly into two groups. So I'm going to highlight that we have randomness there. And they separated them into two groups, treatment or control. They also recruited 38 women and did the same thing. So randomly placing half in the treatment group, half in the control group. One group was given 25 grams of chia seeds twice a day. That right there is the treatment. So that right there is describing our treatment group. And the other was given a placebo. A placebo is a fake treatment. So it'd be something to look exactly like chia seeds, but aren't actually chia seeds. And they should be something like, it should be water or something, like it shouldn't have any effect on the system. So this right there, a placebo is a fake treatment, and that's going to go with the control group. So the subjects volunteered to be part of the study. Something that's doing is it's just emphasizing that we do have volunteers as part of this. After 12 weeks, the scientists found no significant difference between the groups in appetite or weight loss. So that's just kind of giving us a conclusion to the study that the results were not significant, which in themselves is significant. What this would be doing is saying chia seeds do not cause weight loss. So that would be our cause and effect claim that we would like to make, but we need to make sure that there isn't anything in the background at work. So what we're going to do is go through, again, there's lots of vocabulary in here, so we're going to talk about each of those vocabulary words coming up and how we would define it. So, treatment group. This is, again, it's kind of in the wording of it itself. It's the group that's receiving the treatment. So the treatment here is those 25 grams of chia seeds twice per day. So our treatment group, they separated 38 men into two groups and 38 women into two groups. So what that means is that there are 19 men and 19 women. That makes up our treatment group, and they're the ones receiving 25 grams of chia seeds twice a day. Receiving 25 grams of chia seeds twice per day. All right. So that's our treatment group, the group that's receiving the treatment, which the treatment is the thing that we're changing, that the researchers are changing in the environment, which in this case would be giving them those 25 grams of chia seeds. The control group is the group that's not receiving the treatment. So in this case, we're giving them a placebo. We could also run this study without a placebo, but a placebo strengthens it. What we need to see is if there is some effect to like taking something twice a day. Maybe it doesn't matter what it is, but maybe by taking something twice a day, it affects us psychologically in a way that we're more inclined to lose weight or something like that. It's kind of weird, but our brains do a lot of things. So with that, placebo makes it stronger, but a control group really in definition just does not receive the treatment. So even if there wasn't a placebo, we still have a control group here. And it would be the other 19 men and other 19 women not receiving the chia seeds. So that's treatment and control group. And with experiments, we do want these two groups. You want your treatment group and getting their data to see how things have changed with the treatment. And a control group is great to have kind of baseline data or data for comparison with the treatment group to truly see the effect. All right, our next definition here is to talk about blinding with tests. So if you've read articles, maybe you've seen like single blind or double blind experiments before. So let's define both of those. A single blind experiment is where the participants don't know which group they're in. They don't know if they're receiving the treatment or not. So a single blind, participants don't know which group they're in. If a study is double blind, this means the participants don't know and the researchers don't know. So this strengthens it so that the researchers can't be biased in any way towards those that are participating in the study, kind of eliminates any chance of a lurking variable from behavior of the researchers. So this is participants and researchers don't know groups. So they don't know if they're in the treatment or control group. So for this study, if we go back to the wording, it doesn't describe anything. Often there will be a sentence like the participants didn't know which group they were in, or the participants and researchers didn't know how the groups were divided, something like that. This doesn't have any of that. It doesn't necessarily mean that blinding wasn't used, because there's a placebo. So imagine this wasn't blind at all, which would mean everyone knows whether they're in the treatment or control group, which would essentially mean if they're giving a placebo, they're saying, hey, here's your fake treatment. Take these things that are not chia seeds, which would completely defeat the purpose of a placebo. So the fact that they're even using a placebo makes me inclined to think it's at least single blind. You wouldn't want the participants to know they're taking a placebo, so they shouldn't know. We don't have wording confirming that it's double blind, but maybe it is. So what I'm going to do is I'm going to say it's at least single blind because of that placebo that they're using. So blinding just talks about people knowing whether or not they're in the treatment or control group. Double blind is the best scenario to use. That would really strengthen the data and eliminate some of our lurking variables. Has a placebo been used? And that's our fake treatment. And they went ahead and told us that yes, they are using a placebo. So I'm just going to go ahead and answer that with a big yes. So placebo's been used, which means we have at least a single blind experiment. All right, has random assignment been used? So what I want to do is make sure, and this is specific to separating the treatment and control groups, I want to make sure that was done randomly. That separation should be random in doing this. You wouldn't want people to choose which group they're in because that could affect the results. So as I have described before, I highlighted that it said divided them randomly into 2 groups, treatment and control. They did the same thing with women as well. So this right here does have random assignment. Now, you're going to have a scenario where you're designing an experiment, and often students will think this random assignment is the idea of selecting people randomly, like choosing people to be part of the study randomly. And yes, there are benefits to having that be random. But this part of randomized controlled experiment, that randomness is coming from the formation of the treatment and control groups. So this random assignment, I'm going to go ahead and say yes. And just to emphasize, it's when separating the treatment and control groups. As much randomness as you can get in there really only strengthens the study, but especially when choosing treatment and control groups. Has blocking been used? So this will come up every now and then. It's not always part of a study, but blocking is when you separate your groups by some characteristic. Separate subjects by some characteristic. In this case, we have separation by gender. They kind of describe this group of men separately from a group of women. This often comes through when there's stuff to do with biology and like weight loss. Just men and women operate differently typically with that. If they're not interested in seeing how it differs by gender, then they don't need to use blocking. That's fine too. In this case, they did. So has blocking been used? Yes. And if so, what is the blocking variable? In this case, it's by gender. What is the response variable? So response variable is what was measured. So again, variable, if you take it back to our lectures that we've talked about already, so it's like our columns of data. So if we're recording information from these people, we know they're taking chia seeds or taking the placebo. And what we can see is at the end of this, they talk about, let's see, the scientists found no significant difference between the groups in appetite or weight loss. So we imagine they had some values to measure appetite and weight loss. So one variable was probably measuring appetite, one variable was probably measuring weight loss. Maybe they did these both with the same measurement, but appetite, maybe they recorded calories consumed in a day. Maybe it was categorical of how are you feeling today? Hungry, very hungry, not hungry at all. Lots of different options there. For weight loss, that was likely numerical by recording pounds, things like that. All right, so before we get to F, just to summarize. So we have treatment and control groups. Those treatment and control groups were assigned randomly. That's all fantastic. We assume we're working with at least single blind here. Double blind would be even better. And we're using a placebo with the control group. That's all great too. We happen to have blocking in there. And this is all to record information about appetite and weight loss. So can we generalize the conclusion to the population at large? So this is getting at causation. Can we conclude cause and effect? Can we post some article saying chia seeds have no effect on appetite, weight loss? And really with the structure of this one would be yes. yes, we can make those claims. There are things that could make this better. Larger sample sizes are always great. That can always make it better. Something we might want to do is duplicate, meaning run the study again. Get another 38 men and women, run the study again, see if there's no significance there. If you can repeat this and see the same results, that really strengthens it. Something we might want to be careful of, like they mentioned, these were all volunteers, though it's hard to not have volunteers, but there could be voluntary bias for taking part in this study. Who knows what lurking variable that could be introducing. But really, with the formation of this experiment that they're running, yes, we can generalize to the population with this sample result, which could lead to claims of cause and effect. So just to summarize, what we need for a well-designed experiment, and this is the idea that that experiment is controlled and randomized. What we need is control and treatment group that are formed through random selection. So we make those two groups randomly. You can use blocking to separate them by gender or age or any other factors if that's helpful to the experiment, but it's not required. The environment of the control and treatment group should be exactly the same, with the only difference being the treatment. Now, this can be hard to control, but it makes such a difference. If you can make their lives completely the same except for the treatment, that eliminates a lot of lurking variables right there. So if you can make the treatment the only difference between the two groups, that's fantastic. That's often hard to accomplish, but there can be some different ways of controlling that. Another piece is to use a placebo when you can. That's not always the case. An example being, like from the textbook, they describe this an experiment where they conducted surgeries to put in a stent, and they wanted to see the effect of the stent on reducing heart attacks. You can't do a placebo with that. You either have the surgery or you don't have the surgery. You can't have a fake surgery. I'm pretty sure that's illegal. I kind of at least hope it is, that you shouldn't give people a fake surgery that actually doesn't do anything. So placebos, use them when you can. It's not always the case that you can. Often with drug studies especially, or things where they're ingesting something, that's really where the placebo effect can come through, and often they can make some sort of fake thing to ingest that won't affect them. If a placebo is used, then some level of blinding should be used. Double blind is best if it can be implemented. Single blind is good too. So if you have to design an experiment, which I know for a fact you'll need to do, then make sure you have these pieces. Separate control and treatment group randomly. Control group should be getting a placebo if that's possible. And if you could have single blind or double blind so that researchers and participants don't know who's in which group, control versus treatment, that makes for a very strong experiment so that you can claim cause and effect with the results that you get.